I am using the General Social Survey 2022 data set, which is of US adults. It's nationally representative. And the first thing I'm going to do is make a histogram for days of poor mental health in the past 30 days. So, well, I'll show you, and then I'm going to run a mean and standard deviation of it. So I'll show you this first with syntax and then with dropdown. So first, I'm going to make sure that my syntax is going to show up in the log. And then I'm going to weight my data so that it's adjust for sampling error. And so this one is just called weight variable. And now I'm going to graph mental health a histogram. So I'm putting in the name of my variable. This is to generate a histogram. This would give me my mean and standard deviation. This is descriptive frequencies. I can also use that explore or examine. And this can give me both at the same time. Again, this is going to give me more statistics than I necessarily want, right? So I have my mean and my standard deviation. Here's also a histogram. Or same thing with this frequencies. I can add a histogram to that. So I can do my mean, standard deviation, and histogram all together. Finally, you'll see, right, that this has a certain number of cases, and this is weighted. So if I wanted to know how many cases there are not weighted, I could use this weight off. And then when I rerun it, you'll see instead of 1,986, I have 1,904 cases, right? So that'll tell me the actual number of respondents that I have answers to this question about. Okay, let's look at that with dropdown. So first, if I need to show syntax commands in the log, I'm going to go edit, options, viewer, make sure this is checked, and click OK. To weight my cases, I'll go data, weight cases by, and find my weight variable. If I want to sort this, I know it's called weight, and these are harder to look at, these descriptions for me, since I know the variable I'm looking for. If I didn't, I could use a code book. I'm gonna display variable names instead. So I right-clicked on here, and now I just see these, and then I'm gonna alphabetize them instead of having them by file order. And now I just want to click on a W, and it's gonna bring me down to the W variables. So I'm gonna put that into here and click OK. And what if I didn't want weighting? I do the same thing. I go data, weight cases, but now I click on do not weight cases and click OK. Now my cases are, now it's not, my analysis won't be weighted. Okay, so to make a graph of a histogram, I go graphs and histogram. And I put my variable into the variable box and click OK. I can also use analyze descriptive statistics explore. And so this one, I need to make sure that I have both or plots on. If I just do statistics, it's only going to give me things like the mean and standard deviation. And then for plots, the default is the stem and leaf. I don't want that. I want a histogram. Okay, so I need to make sure that I click on plots. The histogram's checked, click continue. Put my variable into the dependent list and click OK, or I clicked enter. And same thing with frequencies. I can do analyze descriptive statistics frequencies and put my variable in here. But here I need to click charts, and instead of none, I want a histogram. And I can say I want, let's say, the mean and standard deviation if I want to run these together, right? Or I could do just the mean and standard deviation and no histogram. I don't want a frequency table. It's going to be too many rows. Okay, so that's how I run everything. So now when we look at this histogram, let's just go back up to this top weighted one. What do you see? I don't see a normal distribution, right? I see the peak here. I see one unimodal, it's a unimodal distribution, like there's one mode, there's one peak, and it's right here at 0 days, and then I see this tail, right? So if I were to draw a curve on here, it would have a big tail to the right. And so this would be positively skewed because the tail's to the right, okay? And that would imply to me that the mean is probably more than the median because this tail is pulling that mean up. It's pulling it to higher days, right? We have some folks who have more days of poor mental health and they're pulling the mean up. I can edit this. So this is frequency. If I go in and double click on the graph and then click on there, I can go to this variables tab, and where it says percent, I can change that to the y-axis, and that'll give me percent instead of variables on the side, which I'd rather look at because it makes it easier for me to know what the distribution is rather than trying to figure it out based on the number of cases as a whole. Okay, so now I can see that a majority of folks were at 0 days, and then you have this tail afterwards. And so I was right about the mean and median because the median is going to be 0 and the mean is going to be is 4.39. So it's like around here. So this mean and standard deviation, these are sample statistics. They're descriptive statistics that are describing my sample. They're not inferential statistics. So this tells me about these 1,900 people in the sample, right, that GSS surveyed. It does not tell me about all US adults. So what we'll start doing next week is inferential statistics, where we use this to make claims about all US adults. This one is not normally distributed, but if it was, then there would be certain properties, right? And so if it was, I would know that, for example, 68% of my data is within 1 standard deviation of the mean and about 95% of the data is within 2 standard deviations of the mean. So I can't make that assumption for here. However, if it were, the way I would do that is by doing those calculations. Okay, so if it was normally distributed, then, and was my mean and my standard deviation, then I would say that about 68% of the data, just over 2/3, would be within 1 standard deviation. So between a value in z equals -1 and a value in z equals 1. So I could take my mean and I could subtract the standard deviation. And I could add the standard deviation to the mean. And that would give you my values here. So I can actually make this. So at z equals 0, let's see if I can make this line up. Right, that's the mean. So that's 4.39. And 1 standard deviation below is -3.17. And 1 standard deviation above is 11.95. So we'd say that about just over a third, 34% about, of data would be between 4.39 and 12 days of poor mental health, and another just over a third would be between 4.39 and -3.17. That's kind of a mathematical theoretical distribution. We know that this can't actually go below 0. And again, our data was not normally distributed, but if it were, we could make a claim like 68% of the data should be between 0 days and 12 days of poor mental health. For 95%, I just need to extend this out a little bit more. So I already went 1 standard deviation below. I'm going to go 1 more below. So I'm going to subtract that 7.56 again. And then here I'm going to add it again. Oops. And so now I have out here, let's see, -10.73. Again, we know that actually can't go below 0 in terms of real life. And then here, 19.51. And so we're saying that 95% of the data, if this was normally distributed, would be between 0 days of poor mental health and 19 or 20 days of poor mental health. If I did 1 more to z equals -3 and z equals 3, I would end up at 27 days over here. And I would end up, again, still at 0 since I can't go below it. And so we would say that 99.7% of the data, if this was normally distributed, would be in between 0 days and 27 days of poor mental health. And then if you also remember, one way to determine outliers is to say, are they more than 3 standard deviations from the mean? And so regardless of normal or not normal distribution, we could say that anyone that has more than 27.07 days, so 28, 29, or 30 days of poor mental health, who reported that in the survey, they would be considered an outlier.